Okay. You all need to know the double integration trick, which you must know. Okay? This thing will save your life, I swear. Actually, it'll really just save you a shitload of time. So,
Literally save life.
let's suppose, for example, that we had the integral from a to b and the integral from c to d of something that was made out of like g of x times h of y, and we were doing dy dx integration.
Right?
You guys with me?
Okay.
What is special here as opposed to the usual?
Two functions on the interior.
Yeah, you have two single variable functions multiplied together. If they are not multiplied together, don't try to employ this trick. Y'all got me? Okay. The trick is this. You're integrating dy, right? So, what is constant with respect to y?
X.
H of X.
X's are constant with respect to y, right? So specifically, g of x is constant with respect to y.
Oh, you can pull it out.
So because g of x is constant with respect to y, we can rewrite this as the integral from a to b, g of x, times the integral from c to d, h of y, dy dx. Now, how are you going to execute this sucker? Like, what's the thing you're going to do first?
You do the inner.
Integral with respect to y.
Yeah, you're going to do this integral here. But what is that shit with respect to x?
Constant.
That's constant with respect to x, right? So you can.
Put it on the outside.
So this whole thing, integral from c to d of h of y dy, is constant with respect to x. So you can factor that crap out. You guys see that? Like this whole shebang may as well be a number because it is. Right? Like categorically, when you're done with this thing's a number. So you can drag it up front. So we can say we have the integral from c to d of h of y dy times the integral from a to b of what?
Gx dx.
Okay, g of x dx. Guys all with me on that?
Yep.
And then just for cleanliness, we'll write that as the integral from a to b of g of x dx times the integral from c to d of h of y dy. Okay? This thing goes with that thing at the beginning. Cool. So you have an integral of a product, you can make it in the product of the integrals, which is the thing you always wanted to do, but never frickin' worked. Guys remember that? Trust me, I know all of you wanted to do, like, when I integrate x squared times sine x, right, you all wanted to be like, well, that's x cubed over 3 times the cosine, right?
Does this only work with single variables?
Yeah, this only works with single variables, and it only actually works when they're different. So you still cannot play that game with x squared sine x, right? But you can play that game with x squared sine y. You could just integrate the x piece, integrate the y piece with their respective bounds and multiply.
Does this work if it's not a definite integral?
That phrase is perfect and unfortunately doesn't mean anything. Right? So this is a thing I glossed, right? What is an indefinite integral in Calc 3 land? What is an indefinite integral in Calc 1 land?
that?
It's in the back of the book.
Yeah.
No, not an annoying integral, Leslie. What is an indefinite integral?
One where that doesn't have the end value?
Yeah, it's an antiderivative, right?
Oh.
But here I have too many derivatives to talk about, like, what's the antiderivative. Does that make sense? I just don't even have that tool here. You guys see that?
Okay.
Like, the concept of an antiderivative almost doesn't make any sense. And I'm being a little hard on you, Kenna, and I don't really mean to be. Because there is a way to make an antiderivative, but to start with, right, you would have to have a derivative, which is best I can tell at this point should be a vector function, right? Because a derivative is a gradient. So I should start with a gradient and then like pull it back.
Yeah.
But nowhere has it occurred to me to play with those objects yet, other than to use them when I got them from differentiating. Like, I don't even know what it would mean for someone to walk up to me and tell me, like, the gradient of a function is 2x, 3y. I'd be like, good for you. Now you can calculate directional derivatives. High five. Right? But like, why it would occur to me to go find the function with that gradient, we don't know that question yet. That's cool. So, yes, it only works with definite integrals. But kind of only because we only have definite integrals. Cool? Thank you for bringing that up, because I had totally forgotten to tell you guys that.